Everybody please stand and settle yourselves for the prayer. Miss Agabon, kindly lead. In the name of the Father, the Son, and the Holy Spirit. Amen. Amen. So, okay, good morning class. Before you take your seats, please pick up any pieces of trashes. Then kindly arrange your chairs properly. So, Bidel, please check the attendance. So, how are you class? Did you already eat your breakfast? Okay, that's good to hear. So, you have energy to participate and listen for our lesson today. Okay, let's have a review. Who can recall our lesson last meeting? Anyone? Yes, Miss Ortega, you're raising your hand. Okay, very good. It seems that Miss Ortega is really paying attention last meeting. So, this time, I will play a 5-minute video and you have to recognize it properly. Okay? Are you ready? So, here it is.
1, 3, -5 and 8. This is just a row of 4 numbers and this can be represented in different ways. We can write it as an array of numbers horizontally like this, or we can write it as an array of numbers vertically like this. The first part, as you can see, has 1 row and 4 columns, and the second part has 4 rows and 1 column. There's another way in which we can write the 4 numbers. The first 2 numbers in the first row and the last 2 numbers in the second row. All these 3 things you see here are called matrices. Each of these is a matrix, just an arrangement of rows and columns. But how do we properly define it? We can say that a matrix is a rectangular arrangement. But a rectangular arrangement of what? It can be anything. Numbers, letters, other characters, anything. A matrix is made up of rows and columns. The first matrix has 1 row and 4 columns. The second one has 4 rows and 1 column. And what about the third one? It has 2 rows and 2 columns. So a matrix is just a rectangular arrangement of rows and columns. But there is one important condition we need to keep in mind. Each row needs to have equal number of elements. For instance, in the second matrix, each row has 1 element, and in the third matrix, each row has 2 elements. And each column also needs to have equal number of elements. In the first matrix, each column has 1 element. The second matrix has just 1 column, so it doesn't matter. And in the third one, each column has 2 elements. So a matrix is a rectangular arrangement of rows and columns in which each row has equal number of elements and each column as well has equal number of elements. So is this a matrix? Elements A and B in the first row and elements C and D in the second. It is a rectangular arrangement. Each row has 2 elements and each column has 2 elements. It is a matrix. And these 3 are also matrices. Okay, what about this one with 3 elements? Is it a matrix? The first row has 2 elements, but the second one just has 1 element. So it is not a matrix. What about this one with 5 elements? The number of elements in each of the columns is not the same. It's 2, 1 and 2, and this as well is not a matrix. So this is the definition. A rectangular arrangement of rows and columns in which each row should have equal number of elements and each column as well should have equal number of elements.
What I want to do in this video is explore the notion of a matrix outside of the context of a surprisingly good movie that involves Keanu Reeves, and it's actually the first of three. I guess we could call the three movies combined The Matrices. And there is a relationship between the movie, which is about a virtual reality constructed by super smart computers, and the relation and the notion of what a matrix is when you study it in mathematics or when you study it in computer science. And the connection really is that matrices are used a lot when you are simulating things or when you're constructing things in computer science, especially in, frankly, computer graphics. So the super intelligent robots that made the matrix in the movie Matrix were probably using matrices in order to do it, if they actually did exist. Now, what is a matrix then? Well, that's a fairly simple answer. It's just a rectangular array of numbers. So, for example, this right over here, if I have 1, 0, -7, pi, 5, and, I don't know, 11, this is a matrix. This is a matrix where 1, 0, -7, pi, each of those are an entry in the matrix. This matrix right over here has two rows, and it has three columns. And because it has 2 rows and 3 columns, people will often say that this is a 2 by 3 matrix. Whenever they say it's a something by something matrix, they're telling you that it has 2 rows. So you see the 2 rows right over there, and they're telling you that it has 3 columns. You see the 3 columns right over there. I could give you other examples of a matrix. So I could have a 1 by 1 matrix. So I could have the matrix 1. This right over here is a 1 by 1 matrix. It has 1 row, 1 column. I could have a matrix like this, 3, 7, and 17. What is this? Well, this has 1 row. This is the 1 row that we see here, and it has 3 columns. This is a 1 by 3 matrix. I could have a matrix, and I think you see where all of this is going. Figuring out the dimensions of a matrix are not too difficult. I could have a matrix that looks like this, where it's 3, 5, 0, 0, -1, -7. This 7, -7. This right over here has 3 rows. So it's 3 rows, and it has two columns. So we would call this a 3 by 2. Oh, let me do that in that same color. We would call it a 3 by 2 matrix. 3 rows and 2 columns. So fair enough. You know that a matrix is just a rectangular array of numbers. You can say what its dimensions are. You know that each of these numbers that take one of these positions, we just call those entries. But what are matrices good for? I still might not be clear what the connection is between this and this right over here. And at the most fundamental level, these are just ways, this is just a compact representation of a bunch of numbers. It's a way of representing information. They become very valuable in computer graphics because these numbers could represent the color intensity at a certain point. They could represent whether an object is there at a certain point. And as we develop an algebra around matrices, and when we talk about developing an algebra around matrices, we're going to talk about operations that we're going to perform on matrices that we would normally perform with numbers. So we're going to learn how, or we're going to essentially define how to multiply matrices, how to add matrices, how to we'll learn about taking an inverse of a matrix. And by coming up with an algebra of how we manipulate these things, it'll become very useful in the future when you're trying to write a computer graphics program or you're trying to do an economic simulation or a probability simulation, to say, oh, I have this matrix that represents where different particles are in space, or I have this matrix that represents the state of some type of a game. And I know the algebra of matrices, and I know ways of doing it very efficiently so that I can multiply a bunch of them, or I could run a simulation and I can actually come up with useful results. So that's all matrices are, but as you'll see through this, we can define operations on them. And then later on, when you take a linear algebra course in college, you'll learn a lot more of the depth of how they can be applied and what you can use them to represent.
Okay, done. So, based on the video clip, what do you think is our lesson for today? Mr. Lim? Thank you. Another one. Yes, Mr. Abisamis. Exactly. Thank you, Mr. Abisamis. As Mr. Abisami said, our lesson for today is all about matrix or matrices. And before we proceed to our proper discussion, Mr. Ubida, kindly read the objectives. Okay, thank you. So, our objectives for today is, at the end of the lesson, at least 85% of the students are expected to first illustrate how to find the result of matrices using addition and subtraction operations, and lastly, explain how to multiply a matrix by a constant. So, a matrix is a rectangular arrangement of numbers into rows and columns. Each number in a matrix is referred to as matrix element or entry. So, this is example of matrix. So, the 6, 1, 4, negative 9, 24, 24, 8 are what we call the matrix element or the entry. So, a matrix has two rows. Rows is vertically, and 3 columns, which is horizontally. So, we will proceed to operations of matrices, which is the addition. So, we can find the sum of the matrices simply by adding the corresponding entries in matrices A and B. So, here is the example. So, matrix 3, 4, 8, 6 plus matrix 4, 1, 0, negative 9 is equals to matrix 7, 5, 8, 3. So, the calculation, simply add the 3 and 4 is equals to 7, 4 and 1, which is equals to 5, 8 and 0, which is equals to 8, and 6 plus negative 9, which is equals to negative 3. So, to add two matrices, it should have the same size, like the rows must match in size and the columns must match in size. So, for example, a matrix with 3 rows and 4 columns can be added to another matrix of 3 rows and 5 columns. But should be remembered that it could not be added to a matrix with 2 rows and 4 columns because the rows don't match in size. So here is another example. A plus B is equals to matrix A, 4, 3, 8, 7 plus matrix B, 1, 5, 0, 2. Next is we're going to add the first column, 4 plus 1, 3 plus 5, and the second column, 8 plus 0, and 7 plus 2. So, 4 plus 5 is equals to 5, 3 plus 5 is equals to 8, 8 plus 0 is equals to 8, and 7 plus 2 is equals to 9. So, this is the sum of matrix A and B. Next, we have subtracting matrices. Similarly to subtract matrices, we subtract the corresponding entries. For example, matrix 3, 4, 8, 6 minus 4, 1, 0, negative 9 equals to 3 minus 4 is equals to negative 1. 4 minus 1 is equals to 3. And 8 minus 0 is equals to 8. And 6 minus negative 9 is equals to 15. Note that subtracting matrices is actually defined as the addition of a negative matrix. So, for example, let's consider matrix C is equals to 2, 0, 8, 9, and matrix D is equals to 5, 11, 6, 3. we can find C minus D by subtracting the corresponding entries in matrices C and D. So, C minus D is equals to matrix C 2, 0, 8, 9 minus matrix B 5, 11, 6, 3. So, we subtract 2 minus 5 and 0 minus 11, 8 minus 6, 9 minus 3. So, 2 minus 5 is equals to negative 3. 0 minus 11 is equals to negative 11. 8 minus 6 is equals to 2. 9 minus 3 is equals to 6. So, this is the difference of matrix C and D. So, now let's proceed to the scalars and scalar multiplication. So, when we work with matrices, we refer to a real numbers as scalars. The term scalar multiplication refers to the product of a real numbers and a matrix. In scalar multiplication, each entry in the matrix is multiplied by the given scalar. For example, given that matrix A 10, 4, 6, 3. Let's find 2A. To find 2A, simply multiply each matrix entry by 2. So, 2 is the scalar and A is the matrix. So, 2A is equals to 2. Then, multiply each to the matrix entry, which is 10, 4, 6, 3. So, 2 times 10 is equals to 20. 2 times 4 is equals to 8. 2 times 6 is equals to 12. 2 times 3 is equals to 6. So, the scalar multiplication is equals to 20, 8, 12, 6. So, class, any questions or clarifications about the lesson? Okay, no one? Since there's no clarifications, we will have our group activity and I will group you into 4. So, the row 1 will be the group 1. Row 2 will be the group 2. Row 3 will be the group 3 and group 4 will be the row 4 will be the group 4. So, all you need to do is answer the activity by group within 5 minutes. So, your 5 minutes starts now. Okay, time is up. Pass your papers and in 5, 4, 3, 2, 1. So, how did you answer the activity, class? Okay, do not answer in chorus. Yes, Miss Ortega? Alright, very good. So, this time, get one whole sheet of paper and answer the following equations. I will give you 10 minutes, so starts now. Okay, time is up and Mr. Lim, kindly collect the papers. So, class, what have you learned from the discussion? Okay, Mr. Torno? Okay, thank you. Another one. Yes, Miss Labasan? Alright, thank you. So, for your assignment, kindly research and study about the transpose of matrix. So, that should be all, and see you next meeting.